Welcome student to my YouTube channel Bharat Chem Study. Today we are going to study about chapter 6 Electrolysis for 10th standard of ICSE board. In this video part 2 we are going to study about the activity series to describe the tendency of migration of ions towards electrodes, electrolysis of molten lead bromide, water and copper sulfate. So let's start with the topics. The activity series. The arrangements of metal in the decreasing order of their activity from top to bottom is called activity series. This we already have studied in our previous classes also. कल्लू नाक का मैनेजर आलू जरा फीके पे खाता है क्योंकि हरी आगे पटना आएगा. So important information conveyed by the activity series for the migration of ions towards the electrodes. The metal present higher in the activity series has more tendency to lose electron and less tendency to gain electron. For example, if we compare sodium and zinc, because sodium is like up in the activity series, so it has more tendency to lose electron and has less tendency to gain electron as compared to zinc, whereas as compared to sodium, zinc has less tendency to lose electron but more tendency to gain electron. So the statement means that the cations of metal present above has less tendency to move towards cathode, and cations of metal which are present below in their activity series has more tendency to move towards cathode. Let's understand this by taking more examples. If Cu2 positive ion and H positive ions are present together in the solution, then Cu2 positive ions has more tendency to move towards cathode and to gain electron as compared to H positive ions, because copper is present below hydrogen, therefore it has more tendency to gain electron as compared to hydrogen ions. Similarly, if Na positive ion and hydrogen positive ion are present together, then H positive ion has more tendency to gain electron and to move towards cathode as compared to Na positive ion. Out of Pb2 positive and H positive ions, if they are present together, the ions which have more tendency to move towards cathode and to gain electron is H positive ions. Now the activity series for anion, sulfate ion, chloride ion, bromide ion and OH negative ion. From this activity series, it is clear that OH negative ion has more tendency to move towards anode and to lose electron as compared to bromide ion, and chloride ion has more tendency to move towards anode to lose electron as compared to sulfate ions. Always remember that sulfate ion do not migrate towards any electrode. If OH negative ion and Cl negative ions are present together in the solution, then OH negative ion will move towards anode and lose electron, and chloride ion will not move. Cations, that is positive ion, always move towards cathode, that is negative electrode, whereas anion, that is means negative ion, always move towards anode, that is the positive electrode. Always remember these points. Inert electrodes. The electrodes which do not take part in the electrolytic reactions are called inert electrodes, that they will not lose or gain electrons. For example, graphite and platinum are inert electrodes, whereas active electrode means the electrode which take part in electrolytic reactions, that means they can lose or gain electrons. For example, silver, copper, etc. are the examples of active electrodes. A point to remember for the chemical equation in the electrolysis: lead, copper and nickel has +2 charge over them, that is Pb2 positive, Cu2 positive and Na2 positive, and will gain 2 electrons from cathode to form lead, copper or nickel. Always remember the charge over the metal ions, and depending upon the charge over them, they will gain electron from the cathode and deposit at cathode in the form of their metals. And the equation can be represented as that Pb2 positive gain 2 electrons to form Pb. Similarly, copper 2 positive gain 2 electrons to form copper, and nickel 2 positive gain 2 electrons to form nickel. Ag has positive 1 charge over it, that is Ag positive, and will gain 1 electron to form silver at cathode. Why I am giving the explanation of this? Because most of the time the students are writing the equation correct, but they will write the charge and the number of electrons wrong. So that's why it's very important to learn the charge over different metal ions. Only then we will write the correct number of electrons added to them. BrCl has -1 charge over them and can be represented as Br negative ion and Cl negative ion, and they will lose 1 electron to form Br and Cl, and the equation can be written as Br -1 lose 1 electron to form Br, or chlorine -1 lose 1 electron to form chlorine at anode. but single Br and single Cl do not exist. So 2 Br or 2 Cl atoms combine together to form Br2 and Cl2 because bromine, chlorine, hydrogen, oxygen are diatomic. They always exist as a molecule of 2 atoms. Therefore, when Br will be formed, then 2 Br combine to form Br2, and when Cl is formed by losing electron at anode, 2 Cl combine to form Cl2. OH negative ion lose 1 electron to form OH, and 2 OH combine to form water and neised oxygen. Then in third reaction, 2 neised oxygen combine to form O2S. So OH negative lose 1 electron to form OH, and then 2 OH combine to form water and neised oxygen, and this oxygen will not remain neised, and therefore 2 oxygen atom combine to form O2. Now the electrolysis of molten lead bromide. So electrolyte is molten lead bromide. Electrode cell is crucible which is made of silica, that is glass. Electrodes are graphite. Types of ion present: Pb2 positive ion and Br negative ion. So this is a structure showing the electrolysis of molten lead bromide. The reaction taking place at cathode, Pb2 positive ion move towards cathode. They gain 2 electrons and form lead there, which is grayish white in color. Reaction at anode, the negative ion move towards anode and lose electron there. So Br negative ion lose 1 electron to form Br, as Br will not present alone. So 2 Br combine to give Br2 at anode, which is a reddish brown fumes. So observations at cathode is that a silvery grey metal lead is formed at cathode, and a reddish brown fumes of bromine are formed at anode. The important points for the electrolysis of molten lead bromide: first, here silica crucible is used because it can withstand high temperature and is a non-conductor. Second point, here lead bromide is kept in molten state because solid lead bromide is poor conductor of electricity. As in solid state, all ions are held together by strong electrostatic force of attraction, but in molten form, ions become free to conduct electricity. Third, here graphite anode is preferred or used because graphite anode do not react with the reactive bromine vapors. So these are very important questions which are coming from these topics. Now electrolysis of acidulated water using platinum electrode. Electrolyte is acidulated water with concentrated sulfuric acid. Electrodes, platinum rods. Types of ion present: H positive ion and OH negative ions from sulfuric acid and water, and sulfate ions from sulfuric acid. The reaction at cathode will take place as H positive ion move towards cathode, gain 1 electron to form H, but H cannot present alone, so 2H will combine to form hydrogen gas at cathode. The reaction take place at anode. We have 2 types of negative ion, OH negative ion and SO4 negative ion, and we have studied that SO2 negative ion, that is sulfate ion, will not move towards any of the electrode. So OH negative ion move towards anode. They lose 1 electron to form OH. 2 OH combine to give water and neised oxygen, and we know that oxygen will not present alone. So 2 oxygen atom combine to give O2. So these are the 2 important equations for the reaction of at cathode and anode during the electrolysis of acidulated water. So these are very important. The observation is that at cathode, hydrogen gas is formed which burn with a pop sound, and at anode, oxygen gas is formed at anode which rekindle a glowing splinter. A question: why electrolysis of acidulated water is considered as an example of catalysis reaction? The answer is because water is a poor conductor of electricity, and acid just help in the increasing the conductivity of water without itself undergoing any change in the concentration. Therefore, the electrolysis of acidulated water is considered as an acid catalysis reaction. Second question from this topic coming, that the ratio of hydrogen and oxygen formed at cathode and anode is 2:1 during the electrolysis of water. Why? This is also a very important question. The answer is, during the electrolysis of water at anode, 4 OH negative ion lose 4 electrons to form 1 molecule of hydrogen as shown in this equation. So here 4 OH negative ions lose 4 electrons to form water and 1 molecule of oxygen, and since there is no electron built up in the circuit, that means at cathode 4 H positive ion must take up 4 electrons to form 2 molecules of hydrogen as shown in the equation. Hence, hydrogen formed at cathode is double the oxygen formed at anode. In the previous topic, we have written the different equation for anode and cathode, but according to this question, to explain that how 4 electrons are lost and how 4H positive ion has to gain those 4 electrons and form 2 molecules of hydrogen, we are representing the equation in this form. So, during the electrolysis of acylated water, the reaction at cathode and anode can be written in 2 ways. One we have studied previous and another is this second method. So, depending upon which equation you are able to learn, you can write any one of these equations. Now, the electrolysis of copper sulfate using platinum electrode, electrolyte acylated copper sulfate, electrode, platinum electrodes, types of ion present, H positive ion and SO4 negative ions from sulfuric acid which are added to copper sulfate, and Cu2 positive ions and OH negative ions are present. Reaction at cathode, there are 2 types of positive ions are present, but we have studied that out of H positive ion and Cu2 positive ion, Cu2 positive ions have more tendency to gain electrons and to move towards cathode. Therefore, at cathode, the Cu2 positive ion moves and gain 2 electrons to form copper. In case of negative ion, there are 2 types of negative ion, sulfate ion and OH negative ion, and we have studied that sulfate ion will not migrate towards any of the electrode. Therefore, OH negative ions move towards anode, lose 1 electron to form OH. 2 OH then combine to form water and a nascent oxygen, and 2 atoms of oxygen combine to form oxygen gas at anode. So, observation during this electrolysis of copper sulfate using platinum electrode is that cathode becomes thick and a brown substance formed at cathode. At anode, colorless gas which rekindle a glowing splinter, that is oxygen gas, is formed, and the bluish color of copper sulfate solution fades during the electrolysis of copper sulfate using platinum electrode. Now the question arises, why the blue color of copper sulfate solution fade during the electrolysis of copper sulfate solution using platinum electrode? The answer is that since the concentration of Cu2 positive ion in the solution decreases as the Cu positive ion from the solution get deposited at cathode in the form of copper, hence the blue color of copper sulfate fade during the electrolysis of copper sulfate solution using platinum electrodes. Now the electrolysis of copper sulfate solution using copper electrodes, the electrolyte is acylated copper sulfate, electrodes are copper electrodes. Type of ion are present, H positive ion, Cu2 positive ion, sulfate ion and OH negative ions. Reaction at cathode, out of H positive ion and Cu2 positive ion, Cu2 positive ions have more tendency to gain electron. Therefore, Cu2 positive ion move towards cathode, gain 2 electron and form copper at cathode. So the copper get deposited at cathode. And during the reaction at anode, out of Cu2 positive and H positive, copper has more tendency to gain electron, hence Cu2 positive ion move towards cathode. But reaction at anode, here in this case, copper which is acting as the anode will lose 2 electron and provide Cu2 positive ion in the solution. This method is opposite to that the electrolysis of copper sulfate using platinum electrode, because here copper from anode lose electron and gives Cu2 positive ion in the solution due to the nature of electrode. That is, electrodes and the metal ion in the solution are same. In that case, the anode will lose electron and provide metal ion in the solution. So here, the ion present in the solution is copper positive ion and anode is also copper. Therefore, the number of copper 2 positive ions moves from solution towards the cathode. Same number of Cu positive ions are provided by copper anode. So, the observation, cathode becomes thick and a brown substance is formed at cathode, and at anode, the anode becomes thin. Out of OH negative ion and sulfate ion, none of them move towards cathode and act as spectator ions. So the spectator ion means the ions which do not move towards any of the electrode during electrolytic reactions are called spectator ions. A question arises, why the blue color of copper sulfate solution do not fade during the electrolysis of copper sulfate solution using copper electrodes? The answer is that as the number of Cu2 positive ion from solution move towards cathode, same number of Cu2 positive ion from anode moves into the solution due to the nature of electrode. Hence, the concentration of the Cu2 positive ion in the solution remains same. so the blue color of copper sulfate solution do not chase. Learn and note down all the topics studied in this video and do written practice of reactions and observations at cathode and anode. Next video, that is electrolysis part 3, we will study the electroplating with nickel and silver and electrorefining of copper. Please like and subscribe the channel for the latest update. Thank you.